Number 2 on page 226. I'm going to maximize the area of a right triangle with hypotenuse 5 centimeters long. Find the dimensions. So we've got a right triangle. Hypotenuse is 5. Now, maximize the area. I mean, the area of a rectangle when maximized is a square. So this is probably going to be a 45, 45, 90. So we're looking for 5 over radical 2 here. Well, we'll see. If this is x, this is the square root of 25 minus x squared by Pythagorean theorem. So our area function, area of a triangle is 1/2 base times height is 1/2 x radical 25 minus x squared. Change classes. And we'll take the first derivative of this function, which is going to be product rule. Take this as our u, take this as our v. Alright, so the first times the derivative of the second. Plus the second times the derivative of the first. Alright, the first times the derivative of the second plus the second times the derivative of the first. I'll set this equal to 0 and clean it up some. Luckily, we don't have to do a second derivative test on this because we know this will maximize. Because you can get long and skinny, it's a very, very little area. Then it gets fatter and fatter, and then it gets skinny and skinnier again. So, cleaning this up, let's see here. On top, bottom, let's see, we can cancel this 1/2 and that 2. We have x squared on top. On bottom we have a 2, and then this. And this is negative. So that cancels with that. 2 x's, a 2, that goes down there. And then this one, still just 1/2. 25 minus x squared. So, we'll find out what x makes it 0. Let's see. Bring this over the other side. Squared over 2 radical 25 minus x squared equals 1/2 square root of 25 minus x squared. Now multiply both sides by radical 25 minus x squared. In fact, we'll multiply it by 2 times that. We'll multiply by this denominator. They'll leave x squared on this side. And then on this side, the half will go out, and this will just become 25 minus x squared, which makes this x squared equals 25 over 2, and x equals what we figured, 5 over radical 2, which is the same as 5 radical 2 over 2. Yep, makes a good 45, 45, 90. And if we were to square this and subtract from 25, we'd get the exact same thing as we had. So our dimensions are 5 radical 2 over 2 by 5 radical 2 over 2 by 5. Or I could have drawn a picture. And the area, what is the largest possible area? So we stick this back in for x into our original equation up at the top. Actually, we use this equation because it's easier. So area equals 1/2 5 over radical 2 times 5 over radical 2, which equals 25 over 2, 4, 25 fourths, or 6.25 centimeters squared. Number 3. will be the smallest perimeter possible of rectangle's area is 16 inches. What are the dimensions? Yes, it's the teacher's edition. It's got the answer there. And who would have guessed it? It's a square. It's a rectangle. Smallest possible would be a circle. But here we go. You got some unknown rectangle. Whose area is 16 square inches. And so its perimeter, if this is x, this is x. This 16 is the area. X times whatever this is, 16. So this is x divided by 16. And so is this. Right? X times x over 16. Whoops. There we go. X times 16 over x is going to get us 16. So our perimeter function based on x is going to equal 2x plus 32 over x, which is just adding these up. X plus x, 16 over x and 16 over x is 32 over x. So our first derivative is going to be 2 plus, this is 32x to the negative 1, will be minus 32x to the negative 2, set it equal to 0. Bring this over, multiply, divide, and x winds up 4. And as this is 4, 16 divided by 4 is also 4, so 4 by 4 is smallest dimensions. So dimensions 4 inches by 4 inches, and the perimeter of, you actually put the 4 in there, 1, 2, 3, 4, 16 inches, not squared, it's perimeter. Moving on to number 4. Alright, finding area. Show that among all rectangles with an 8-meter perimeter, the one with the largest area is a square. Alright, so we know intuitively this is true. But we need to show. Calculus is about showing. Alright, so a perimeter of 8. It's got some width or length, which means that's that too. So we've used up 8 minus 2x. Or no, we've used up 2x, so we've got 8 minus 2x left, and so each one of those gets half of that. That'd be 4 minus x, 4 minus x. So if we add up all these, we've got 4 and 4 is 8. Those two cancel, we get perimeter of 8. So we know our drawing is on track. And we want to know that when the largest area. So our area function is going to be length times width. So that's x times 4 minus x. So that's 4x minus x squared. We'll set it equal to 0. Oop. Took our derivative. Now we set it equal to 0. So 4x, don't do that. We have x brought off from 4 minus x equals 0. What am I doing? Start that again. Here's a of x, our area function. We take the derivative of this area function. Helps in calculus if we take the derivative. My bad. Alright, so minus 2x. Now we set it equals 0. That means that 2x equals 4 and x equals 2. So if x equals 2, that makes this 2, this 2, this 2, and this 2. They all wind, it does in fact wind up being a square. So forgetting to take the derivative aside, all works out as a square. Let's try number 5. Figure shows a rectangle inscribed in an isosceles right triangle whose hypotenuse is 2 units long. And I want to express the y-coordinate of p in terms of x. y-coordinate of p in terms of x. All right. According to p, if this is 1, I'm sorry, isosceles right triangle with hypotenuse is 2 units long. So this is 1 here. This is 1 here. So this is at a 45-degree angle. So the y-coordinate is just the x along this line. And this is clearly the line 1 is our y-intercept. And our slope is negative x. So a negative x plus 1. B, express the area of the rectangle in terms of x. The area function, so our length here is going to be 2x, and our height is going to be negative x minus 1. So our area function based on x is going to be 2x times negative x plus 1, which would be 2x times 1 minus x, which would be 2x minus 2x squared. And what is the largest area the rectangle can have, and what are its dimensions? All right, so once we have the area formula all laid out already, we can take the derivative of it. Minus 4x says equal to 0. So that means that x equals what, a half? All right, so its dimensions, x equals a half. That means that this is a half, and it's a half this way, so it's 1 by something. So dimensions are 1 by, that's an x for by, not 1x. Now if we put in 1/2 up here, negative 1/2 plus 1 is 1/2. And is there 1 by 1/2? Number 6, we'll leave for next video. Number 6.